Next, we talked about case when we change the coefficients of a basic variable. If the variable xj under consideration is a basic variable in the optimal solution shown by the final simplex tabular, then after replacing the new column, the variable is not in proper form from Gaussian elimination. Thus, we need some extra work in this case. Again, we look at the example. Recall that the rule for replacing the coefficients in the objective function for xj and the column vector is still the same. If we change the coefficients of xj, then the coefficient in equation 0 will still be y star aj bar minus cj. And then the coefficient in the final tabular for the rest of the equations will still be aj star equals s star times aj bar. So now let's consider this example again. So this is our original linear programming model we have its final simplex tabular. However, in this case, now let's consider x2. It was a basic variable in our final simplex tabular. Consider now if the coefficients of x2 are changed from in the objective function 5 to 3, and then in the constraints from 0 to 2 to 0, 3, 4. What happens? So in order to do that, again, we will see what to replace in the final simplex tabular by these formulas. So again, we do the matrix multiplication and we see the new coefficient of the x2 in the objective function in equation 0 will be y star, the value of the slack variables in our final simplex tableau, times a2 bar, which is the new column vector 0, 3, 4, minus c2 bar, which is the new value of the coefficient in the objective function we replaced 3. So by doing this calculation, we say the new coefficient in equation 0 will be 7. And then similarly, the column vector will be S star, again, the matrix of the slack variables, times A2 bar, the column vector in the new with the new coefficients. So after this computation, we find out we are going to replace the column of x2, originally 0, 0, 1, 0, to a column of 7 top on top, and then 0 to -1. After doing this substitution, we see that, well, originally x2 is one of our basic variables, so it must have a column vector of a unit vector, 0, 0, 1, 0. However, after doing this substitution, our new column is not in the proper form as a unit vector anymore. So in this case, we need to add some extra work to do Gaussian eliminations so that this column becomes a unit column again, and then start from there, check if this BF solution is still feasible or optimal. So then we do Gaussian elimination to first make this value 1 and then do elementary row operations to eliminate all the other coefficients in that column. After we calculate the tableau properly, we can see that now in equation 0 of this simplex tabular, we have one negative coefficient. So we have to apply the optimality test. There is one negative coefficient, so this is our pivot column. x1 is the entering basic variable. Next, do the minimum ratio test and find out that in this case, x3 is the leaving basic variable. And then do Gaussian elimination to change that column a unit column of the form 0, 1, 0, 0. Since this is a 1, it actually saves some work. After doing that, we say, well, x1 is entering and x3 is leaving. With this new tableau, we can see that the right side are all positive. So this is feasible. The top row are all non-negative. So this also passed the optimality test. So at this point, after actually one iteration, we obtain a new optimal solution in this case. So this is when we change the coefficients of a basic variable. The only difference here is that after change the coefficient in the basic variable, after replacing the column vector, this column is not unique column anymore. So we need to do one more extra work, one more step of the Gaussian elimination to make it a unique column, and then check whether this passed the optimality test or this is feasible, and then continue until we obtain the optimal solution. Last, summarize the basic procedure for sensitivity analysis. First, we want to revise the model. Make the desired change or changes in the model to be investigated next. Second, we want to revise the final tableau. Use the fundamental insight to determine the resulting changes in the final simplex tableau with all the formulas given. Third, we want to convert our final simplex tableau to the proper form, and then start from there, check whether it passed the optimality test or feasibility test. So for the feasibility test, we want to check if this solution is feasible by checking whether all its basic variable values in the right side column of the tableau are still non-negative. And then in the optimality test, we want to check if all the non-basic variable coefficients in equation 0 of tableau are still non-negative. And then if this solution fails either test, the new optimal solution can be obtained by using the current tableau as the initial simplex tableau and then apply either the simplex method or the dual simplex method.